live. Welcome on Gelato, the podcast. And I'm here today with Arjun from Everclear, formerly Connext. Welcome, Arjun.
Awesome. Thanks for having me, Luis.
Awesome. So congrats, first of all, on the great announcement that definitely made its waves on Twitter or X yesterday. Very exciting news. I know we've been chatting a bit about it already in the past months, but I'm super excited for this. I think it's a nice sort of, I guess, pivot for you guys. Maybe not it's still very related to what you did before, but it is something fresh for sure. So yeah, let us know what are you guys cooking over there, you know?
Yeah. I mean, thanks for the congratulations. I think we are super blown away by the response that Everclear has received on Twitter and throughout the space. There's been some really awesome questions coming in around it. I think one thing that's been really, really fantastic is that a lot of people have independently reached out to me being like, hey, I get it. And I'm like, that has been really surprising because we were sort of completely going into this preparing for this outcome where we were like, okay, we're probably going to have to and we will still have to spend lots and lots of time explaining it and working through how it all works and why it's necessary and things like that. But it was awesome to see that there were a lot of people that just got it from the original tweet thread and from our positioning. I mean, from our side, we're super excited about this. We think that there's not just a huge need for something like Everclear in the space. Clearing is a concept in traditional finance and really the broader systemic system of clearing, or basically having a meta layer that sits between a commitment to a transaction and then an underlying state change. In information theory, this kind of pattern of having something that sits between those two steps is very, very normal, and is a fundamental part of how systems work efficiently. And so we from our perspective, we see this as we think that this needs to exist because it's a sign of maturity for the space, that we've hit this point where we have enough users, we have enough interesting developments happening that it's worthwhile to actually invest into this kind of technology. And we're just really interested in seeing what it looks like to build this out with the community.
Cool. And you already sort of started giving some parallels to, I guess, the TradFi world. And I feel I think probably this is the same for many people in the space. A lot of young people in the space, right? I certainly started in crypto when I was still very young, in my early 20s. And a lot of people, I think, I often discover this, I learned so much about the existing world from crypto, basically from reverse engineering from crypto, from the crypto perspective, and only this way understanding how banking works, how clearing houses work, and this and that. And I feel many people in crypto are learning about the quote unquote real world or Web 2 world, whatever, the TradFi world, the boomer world, right? They learn about it by basically understanding what crypto is solving for. And this phenomenon I think is really cool. Sometimes it makes me question what the hell schools and education are doing these days, right? that we have to learn it from the revolutionaries. But yeah. So maybe how about you first spend some time giving us a sort of easy to understand analogy of how things work in the TradFi world as pertains to Everclear, right? What would be your perfect simple analogy? And then from there you can go on to how things currently work in crypto with, cross-chain bridge operators the Connexts, the Acrosses, and whatnot, and how maybe this was the case in the traditional world before as well, but then you had clearing houses and Visa and so on come in, and how this is now essentially what you are bringing to the crypto world. Let's take that arc for a couple of minutes.
I think this is a really great way to explain it, because I do think that there's it seems to resonate with a lot of people because you kind of experience this with how you use finance today. So let's start by defining what is clearing. Clearing as a term, we specifically chose this term because we didn't want to introduce yet another term to the space. Clearing has a very established meaning in finance. And while clearing does not, in our case, does not necessarily need to be purely financial, it is a largely financial thing that you're doing. Clearing in finance is everything that happens between when a transaction is like authorized or executed, which means basically like the user's portion of the transaction is complete. They've like in the case of like a card payment, for example, authorization is what happens when you like pay with your card at the restaurant and they give you your food, or like you buy a coffee. And then everything that happens between that and then final settlement, where settlement is the money actually gets moved, is clearing. As it turns out, there's a bunch of things that need to happen between those two steps. In traditional finance, basically, with there's a lot of great examples of this. So I'll talk about two. One is Visa, and the other is the New York Stock Exchange. And they both work quite differently, but both of them are effectively clearinghouses. When Visa, in between those two steps, right? What Visa does is Visa authorizes your card payment, which basically means they communicate with the merchant to tell them, hey, we have gotten a record of this transaction happening. Then, and of course the merchant says, okay, at this point, Visa owes me money. Visa has effectively like issued an invoice to me and I can go after them if they don't pay. Then the kind of user part of the transaction is complete and Visa goes and starts their like kind of back-end administrative process. So what Visa does is a few things. One, they take all of the authorizations within a certain period of time. They usually do this like at the end of the day. They'll do this per merchant, and then they'll also end up kind of doing it across all merchants globally. They'll take all of these transactions that are pending, they'll lump them all together and aggregate them, and they'll net them off. So what is netting? Netting is a really, really important concept that exists in finance, but it just exists in systems in general. Like you get netting. Netting happens in like distributed systems as well. It happens in like any system where you're kind of like updating state multiple times between different state containers. You can kind of like net off those changes. So if there's like, it's like if I need to like add something to a database and then like 2 seconds later delete it, I might as well just not add it in the first place. Netting is basically this process by which you take a bunch of interactions, a bunch of state changes between different agents or state stores or distributed systems, and you basically sum or aggregate all of those interactions to come up with a single final interaction.
And just very quickly for the listener, if you're not watching the video, Arjun just like 10 seconds ago started to share his screen, and if you want to follow along visually, there's a nice chart here that maybe helps you understand the concept of netting. But yeah, continue, please. Yeah,
definitely look at the image on the screen if you can, because generally speaking, we found netting is actually really hard to explain until you see this image. And then as soon as you see this image, you're like, oh, okay, I get it. Yeah, it's actually not a very complex concept. You see netting like everywhere. So a good example is something like Splitwise, for instance, where like a lot of people will use Splitwise. It's an application that allows you to like split bills with your friends. And what you do is you just, instead of like, Luis, I owe you funds and you owe Hilmar funds and Hilmar owes like someone else funds. And then they, it's like, instead of having these like single peer-to-peer payment relationships, we all just register our relationships with Splitwise, and Splitwise just calculates this final output, of like, I owe Hilmar $10. When everything has been settled, I will owe Hilmar $10. You can see why this is super important, right? Like if in a world without netting, we're just paying so much more money to actually do transactions than we need to. And so, yeah, that's kind of the middle step for Visa is this netting process where they're kind of aggregating all these transactions and they're reducing the overall amount of like settlements that need to happen. And this makes sense. It makes sense because, for example, there are likely very, very large amount of, say, for example, this is Bank of America and this is Chase. There's likely very, very large amounts of value flowing between Bank of America and Chase, like going in both directions, right? Because those banks transact with each other all the time. And so by aggregating these transactions and having like a final settled netted amount, the total amount of money that needs to be moved is a lot lower. And then the last thing that Visa will do is they will then take all of this information about like aggregated transactions, the final amount of balances that need to be moved, and they will go and deliver that to banks to do final settlement. Banks will do this via like settlement rails like Swift, like Fedwire, Bankwire, or whatever. It kind of depends on the jurisdiction. It depends on like where the payments are going.
Yeah. The way I would describe this, and by the way, I looked at some of your docs, and I think indeed netting is it should be easy, but it is actually quite hard to grok a bit. And I have to say the diagram is already helping, but I'm still confused, especially I don't know why there's J, M, K, and S. Maybe if they have no purpose, remove them because they're definitely like off-putting for me. Yeah. But how I would describe this, roughly speaking, and maybe this is also where people that are familiar with sort of token market making across chains, like across chains, like across Connext, Stargate, whatever. Basically, how I would describe this world is we have in this diagram as well, we have 4 parties with transactions between each other, inflows and outflows. And having a clearinghouse in my mind right now is like taking the global aggregate view, and then essentially looking whose inflows in a given time period matched their outflows. These are perfectly netted off. Their inventory looks the same, right? Okay, maybe they made some fees, great, but they don't have an issue. So exactly. the question then is who has a surplus and who has a deficit in that same time amount, and then you need to basically try and repay the party that has a deficit from the party that has the surplus, and that's essentially what happens with netting. You take the aggregate view. Everybody who's break even in that time period, you're fine, nice. You don't need to do anything. The parties that have afforded the surplus, or the parties that have gotten the surplus, need to repay those that got the lower end of the stick and that were actually paying out more than they got. And that's really cool because now you can essentially reduce the settlement, I guess, of transfers to an aggregate. In this example. Exactly. In this example, you don't have to repay everybody who already got an inflow, right? Like you don't have to, which is currently what happens is like everybody just like currently needs to rebalance their inventory and themselves. In this case, the clearinghouse sort of does this aggregate view, this aggregation, and then it makes sure that the parties who have gotten the deficit, who actually in this period provided a good service, get it refunded by those that have accrued a surplus. That's how I would think about it.
Exactly. Yeah. And so yeah, that's kind of how Visa works. New York Stock Exchange, very, very similar, right? So why does clearing exist in the New York Stock Exchange is a clearinghouse. They run a central clearer. And I'll talk a little bit about what that means and like what the difference is between a clearinghouse and a clearing layer in a moment. But New York Stock Exchange, very, very similar situation. Everybody that is trading, like stocks that are traded on the New York Stock Exchange, are trading in a bunch of different avenues. And so like you might trade on Robinhood, some other people may trade like maybe actually putting in like OTC trades and things like that. All trades that happen in a period are being registered with the actual clearinghouse. Because if they're not registered with the clearinghouse, the trade is not considered to be executed. And the clearinghouse is the thing that actually does this final settlement. So the clearinghouse basically takes all the trades that are happening between everybody, and that includes just like tons and tons of high frequency trades, right? Because there's like bots and individuals that are trading like sometimes on the order of like milliseconds between different counterparties, and they're just arbitraging constantly. And they're doing this because that's how prices stay stable in the stock exchange, right? That's how we like get like good market views, is that there's constantly people like arbitraging and like pushing prices in the direction they need to go. But this means there's a lot of volume. There's just a lot of trade volume happening all the time. So this New York Stock Exchange runs this central computer that basically everybody registers their trades with, including all of these like extraordinarily frequent teeny tiny little arbs. And the stock exchange, the NYSE clearinghouse then turns all of that into a final netted flow at the end of the day. And so when these trades are actually like finally settled, and I can talk about what settlement means in a second, but when these trades are kind of finally settled, the amount that actually gets settled is much lower than the total value of all of the trades that have been executed. So what does settlement mean in this case, and why did a clearing, or how did this whole process actually start? So until the late 1800s, people were not really using clearinghouses. The New York Stock Exchange actually was not using a clearinghouse until actually far later, I think almost like 30 years later. And this was a shit show because this was a time when like trading stocks meant actually getting a note, a piece of paper that you had to physically hand over to someone, and you had to have people attest to the fact that the physical note had been handed over to someone else. And so of course, like the process of settlement meant actual delivery of assets, right? It was not like, oh, we've settled on chain, or we've settled in like a computer somewhere. It's like, oh, I actually need to have physical bearer custody of this like thing that shows that I own this stock certificate, like literally a stock certificate. I think this changed because it's a very, very fun fact. In like the 1880s, I think there was this like a lot of other organizations, financial organizations, started to run on clearinghouses because they just realized it was a much more efficient model. Because they realized like the operational complexity of literally physically going and delivering certificates to different people on a peer-to-peer basis just wasn't working, right? It just doesn't make any sense. And so what they did was they created a central entity that everybody goes and gives the certificates to, and then that central entity is responsible for then like doing the final delivery as well. And the New York Stock Exchange actually resisted doing this for a while. As I mentioned, they actually were like a late adopter of clearinghouses. And a fun fact here is that there was this other entity that spun up out of Pennsylvania that actually started to effectively like vampire attack the New York Stock Exchange. I don't remember the exact name. I think it was called the Consolidated Stock Exchange of New York or something like that. And they ran their own renegade clearinghouse, and the renegade clearinghouse was so much more efficient at like trading that they ended up capturing like, I think it was like 20-something% of the total volume of the New York Stock Exchange before the NYSE was like, okay, this is ridiculous. We have to run our own exchange. And that's when they kind of like switched over to clearinghouses. Now, what's the difference between a clearinghouse and a clearing layer? Clearinghouses, typically in traditional finance, refer to like a central counterparty, a central clearer. A central counterparty basically means that like instead of you and I transacting with each other, both of us go and transact with what is effectively a bank, right? That bank is holding custody of our assets, and holding is the like custodian that is deciding how all of the clearing happens and how everything gets settled. Historically, people have been trying to research decentralized clearing, so basically peer-to-peer clearing mechanisms, for honestly decades now. But it's never really worked. And I think the reason that it's never really worked is that if you are actually doing true peer-to-peer clearing, where like I have an obligation to you, you have an obligation to someone else, blah, 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 you have to kind of traverse this like extremely complex graph to figure out how to do all of the netting. And doing that for like an unbounded set of parties is an NP hard problem. There's no actual analytic solution. You can compute it with a lot of computing power, but it's not like a very efficient thing to do, and you're not going to get the kind of performance that you would get versus having a central clearer who is like the counterparty to every trade. Basically, another way to say this is that in distributed systems, like hub and spoke systems are inherently, like in any kind of like graph theory, right? Hub and spoke systems and traversing a hub and spoke system is always going to be inherently way more efficient than traversing like a true mesh system. There's only like very rare cases where you actually want a true mesh system, even in a decentralized paradigm. Now, the key unlock here is that like a clearing layer is not a clearinghouse because it's not a central custodian. There's no custody risk at all. What a clearing layer is doing is everybody's like putting money into like registering money in the system by putting money into these like gateway contracts on each chain. But the clearing layer, Everclear, is just computing the optimal outputs for everybody. So in a way, it's more of like a peer-to-peer decentralized clearing mechanism, except that everything is computed in the same state machine. This is like one of the unlocks that we get out of blockchains that just like has just never existed in the past, where people are like, okay, I need to run peer-to-peer software to run this. But now we're like, oh, we can have replicated state machines. So I could replicate this like state machine that is computing optimal clearing strategies, and anyone can run it. It can be verifiable. It's decentralized. It doesn't have to be like a central custodian anymore. But at the same time, it's still providing the best, like the same kind of performance as something like the New York Stock Exchange or whatever would. Yeah. So this is kind of like a high level answer.
Nice. Quickly, do you have some more slides that you wanted to show, or should I quickly unshare your screen so we have the view on our tiles again?
Oh yeah, I'll unshare. So there's
right.
I can jump back into basically from here I'll jump into like, well, how does this tie to this space, and like where does the clearing layer fit into this space, and like why is it actually necessary?
Cool, nice. Yeah, feel free to reshare your screen whenever you feel like it, and then stop sharing once you're done. So let me first unpack what you just said. So you gave a nice historical overview of clearinghouses, what clearing means, settlement, why clearing wasn't really peer-to-peer ever, even though there were attempts in the past. Usually it did require a centralized intermediary, right? I mean, Visa is a sort of consortium, I guess, but still it is some like a centralized intermediary. I guess at the end you then jump to Everclear, which is your project, and how that is different as a clearing layer from a clearing house, right? It's not just another centralized visa for blockchains, but it's something a bit different than that, using blockchain technology and so on, right? Or rollup technology. So before we go there to Everclear, like, let's try and unpack some of these sort of powers that a clearing house would need to have. Because, like, for me, I remember back in the day when I started looking at blockchains in 2016, 17, it was like, oh, the blockchain is the settlement house. It is the clearing house, right? Awesome. You don't need that anymore. Like, the blockchain does it for you. That is true in a single chain context, because every transaction is settled in a block, right? And Ethereum is a settlement layer. But what happened, right? Okay, this stuff didn't scale. And now first we had many alt L1s, and now we have many rollups, and in the Gelato vision, basically infinite number of rollups at some point, right? Like, block space should be abundant and commoditized. And yeah, now you have the same issue, I suppose, again, because now you cannot settle between blockchains. You need a centralized intermediary to do that. And that is what we are somewhat seeing with all of these centralized / semi-centralized / somewhat decentralized cross-chain messaging protocols and so on, right? Like, not throwing shade here, but you know, like, we all know that there's a strong degree of centralization in them today. And and clearing is another issue, like, I guess, because clearing is more like, okay, you probably actually can work with any such system, no matter if they're centralized or decentralized, but you just provide a different benefit to them, which is essentially like a clearing capability and netting and efficiency of capital management. But yeah, so what has to happen on a clearinghouse for them to be able to do their efficiency and so on? Is that basically that they have access to everybody's account and money, and they move it for you, and you trust them? Like, are you fully trusting the clearinghouse? And are you basically saying, hey, I give you access to my trading or bank or whatever accounts it is, and I'm trusting you to correctly clear and settle, and then you move my money as needed, and you give me money from others as needed, and we observe the system, and we hope that you're not fraudulent, and that we all net out perfectly with each other as per what we have done on that given time period, right? Is that sort of the idea? Like, a clearing house needs this full access, this full control?
Kind of. So let me take a step back to like what you touched on before, which is like, in the past we'd sort of said, okay, like, there isn't really a need for things like clearing on blockchains, because, like, you know, blockchains are settlement layers. You can just directly register your transaction with the settlement layer and things like that. But ultimately we find that, okay, that doesn't scale, and now we need L2s and stuff like that. When you zoom out a little bit, I think, like, this makes sense, right? I think every like early programmer makes this mistake at some point, where they're like, okay, I can just build a really, really simple system to go and like directly make updates to this database. And like run a web server that is just pushing updates directly to a database. And you're like, okay, this is such simple code. I don't understand why anybody else and we're doing anything more complex. And then you like run it in production for a bit, and eventually it grows and grows. And once you start to get real scale, you realize this isn't working. And it's not working because, like, when you're making updates to this database, that database needs to lock. And so now there's like latency, right? There's like limitations to how far and fast you can scale this database, and how far and fast you can go and retrieve data from it. And so then you start like creating secondary measures. You create basically layers on top of the database, things like caching, things like queues. And you do this, and eventually you like fragment your database into a distributed database. You do this because fundamentally, right, like the pattern that exists for making changes to some shared global state must involve some amount, I mean, especially as that global state grows, has to kind of involve some amount of like basically some amount of caching, something in between that is like registering interactions at a faster basis that then makes updates to like a slower backend database or slower backend settlement layer. And that's effectively what we've done here in this whole space, right? We've taken like Ethereum as this like slow settlement layer, which is like this database, and we've scaled it by adding like caching and shit like that on top. And I think clearing is just like a testament to that. So it's basically a manifestation of the same core fundamental information theoretical principle, or the same core like systems design principle. And like this also, the same sort of challenge also exists in finance. Now, what is the kind of difference here? Like, what kind of powers does the clearing does clearing in general need, specifically like clearinghouses, and then also the clearing layer? If you want to do clearing really effectively, right? The mechanism behind clearing works well when the system that is doing clearing has two things. One, a very, very like as global of a view as possible of the flow of liquidity or state. You know, if we're talking very general terms of state, but in this case, let's say like it's flow of funds. It's a very, very global view of the flow of funds. It needs to be its own system that can access as many flows as possible, because the more flows it can access, the more netting you can do. And so ideally, you don't want to have many, many, many clearinghouses or many, many, many clearing pairs. You want to have one system that is being used, or maybe a couple of systems that are interoperable or something like that, right? This is the reason why there's not more than one clearinghouse in the New York Stock Exchange. This is the reason why Visa and MasterCard, they're really the two large payment clearinghouses. There are others, but they don't really have a ton of traction. They usually piggyback on Visa, MasterCard. So that's kind of one. The second is the system needs to have the ability to then decide how settlements occur. And people need to trust the system to decide that. Now, how they trust the system is another question. So in traditional clearinghouses, you just trust the system, right? You just trust that the New York Stock Exchange is not going to rug you. You trust that they're going to order your trades correctly. They don't always do that, right? Like the trades are registered in a bunch of successive places until they get to registered on the New York Stock Exchange. And in between, all of these intermediaries are like reordering your trades and like, you know, like basically backgrounding you and like making a bunch of money off of you. So that's kind of like one like inherent limitation in TradFi. And then in addition to that, you're also sort of trusting in TradFi that like, okay, like, you know, all of this is custodial. So like there is like this explicit custody risk of like this entity is holding my funds and is going to give them to me later. And they're going to unilaterally decide how and when that happens. And they might choose to rug me. There's not anything I could do about it. For the clearing layer specifically, there's a similar requirement where the system needs to be able to, again, if it wants to be very efficient, it needs to be able to plug into whatever settlement mechanism that it can.
And just to not lose the listener here, when Arjun is referring to the clearing layer, he is essentially talking about Everclear, the basically the new invention. Has the word clearing layer be like, is that like a common thing, or is that sort of your thing for Everclear?
Yeah, we wanted to kind of come up with a word to describe this primitive. We wanted to make it clear, no pun intended, that this is like the fundamental position that this occupies is to do clearing. But we wanted to also make sure that it's very clear, again, no pun intended, that this is not a clearing house, right? It's something that's quite different. And so the two options that we came up with were clearing layer and clearing chain. We had an internal vote on it, and people liked layer more, so we went with layer.
Cool, that makes sense. Yeah.
Yeah.
Nice. Cool. So yeah, I interrupted you there. So maybe just before you go to the challenge that I guess the problem statement that the clearing layer is trying to solve. So essentially from your speech there in the last 2 minutes, I basically learned that there are super high degrees of centralization in traditional clearinghouses, that these are essentially monopolies almost. Like, I mean, Visa is certainly the biggest one for credit cards, right? And then New York Stock Exchange just has one. And ultimately it is economies of scale. And again, we see this Moloch that you're very familiar with, Moloch, I guess, from back in your days, right? Like, again, where centralization eats everything, because it's just like, you know, everybody like has to defect to it because it's just the most efficient way to do things. But you end up with these huge power centers like Visa and so on, like that are making huge fees nowadays, that have insane business models, right? And yeah, so already foreshadowing the later part of our podcast is like very interesting to see how this fits into the blockchain world, right? Like, and how you're distinguishing yourselves from these clearinghouses. So yeah, we have established then the clearinghouses do exist and are very centralized in the current TradFi paradigm. And one thing that I wanted to get at is like, I feel you could say that there has been a similar modularization of the TradFi stack, similar to what we see nowadays with the blockchain stack. We have the settlement layer Ethereum that used to be settlement layer clearing and whatnot. And now that we have Ethereum isn't alone anymore, there's all of these other rollups and chains that it has to interact with. People have accounts on all of them, and we even want to chain abstract that so that it should feel like one account to them sometimes, right? Like, suddenly, like we see like Celestia and some what they're doing, like suddenly Ethereum isn't alone enough to be a clearing house or layer anymore, right? Like you need something like Everclear apparently, right? Because we now have all of these other destinations, and once you lose the single chain context and you have a multi-chain context, suddenly you need a new clearing re-intermediation almost, right? So
yeah.
So,
no, I would actually say even in a single chain world where Ethereum was the only chain or the only settlement layer, you would still need a like clearing mechanism, and you would need this for both order flow, which is what we're doing, so like capital flow between chains, and then also block space, which is basically what shared sequencers are, or like a shared sequencer ordering network, something like.
But I guess in the single chain,
like
in the single chain context, you don't really have shared sequencing or so on. It's all there already, right? Like I mean,
sorry, single chain with rollups. So like
yes, but sorry. Maybe given that you're probably like a roll-up friend, I misused the word here. But like when I say multi-chain, I still mean also an L2 roll-up, even if it's stage 2 on L2B today. Like it's still like different chains, right? All right. So then maybe like what happened similarly in with Visa and so on in the banking world is that like actually I've heard this, like I recently interviewed someone and they told me that they worked in fintechs before and that they were surprised to see that a lot of the fintech consumer apps that people use is like obviously it appears like you're magically sending money around between banks, but in reality this fintech just has pots of liquidity in all of these banks, and they literally do what Connext or Cross and so on do, and they just like sort of give instant liquidity to people on these banks. So I guess like similarly to that, you at some point in the TradFi world had this this moment where basically instead of everyone doing this, which is the current state of blockchains, like across Connext, Stargate, they all operate in their silos and they all put liquidity on all of these accounts, like on all of these blockchains, right, where they manage it for their user base. Instead of everyone replicating that and not sharing this, you now have a new intermediary, like the clearing houses in the TradFi world, clearing layer, Everclear in our Web3 world, which is now again allowing them to net out in between each other, so that if you paid out someone that wanted liquidity on your chain that you're on or your bank account that you were on, you can basically get this money back if someone else paid you that money on another bank account or another chain, right? Like even though that user might have been coming from a different market maker protocol, bank, whatever, right? Like so again, we essentially need somewhat competitors. This was the same case for Visa, right? It's a bit different in the New York Stock Exchange, but in the context of Visa, we have all of these competing banks. Actually, Visa originally was Bank of America, right? Like, so literally you had a bank of America, so this amazing guy, there's an amazing episode I shared with you from Acquired, right? Basically, this guy pulled it off and he convinced all of the other banks that the sum of the part, like is the sum of the parts is bigger than whatever, like however the saying goes. So he was able to convince his competitors that they should all join this conglomerate, this consortium, and because the benefits would be there for everyone, and it turned out to be very true, right? Like so, I feel like if Everclear becomes true, it will follow a very similar path where ultimately competitors that are today the Acrosses, the Stargates or whatnot, they should feel compelled to join this network because all of them will benefit from it, even though they are collaborating with their competitors. Like ultimately, their capital efficiency, their business should still benefit from being part of the network rather than not being part of it. That's like a bit of a side story and so on, but is that sort of analogy true? And now I guess let's go to the real question of, okay, what's different in Web3 than what are we about in Web3?
Yeah. So that analogy is very, very true. I think that there's a few things that we've kind of found over the course of like starting to share Everclear with the world and starting to talk to other projects. Because we've been talking to, I mean, it's like if you're building a project, then sometimes the people that you're closest to are your competitors because they understand your problems extremely well, right? They're like dealing with a lot of the same things you are, and you might like ideally what you want is an environment where you have like healthy, friendly competition with other people, and like you can like work. You can sort of like solve problems together, but also like work on making your business succeed. I would say like there's some projects in the space that we absolutely have that with, and like I think that in general what we found through Everclear is that by like shifting focus towards solving shared problems for everybody, we've actually like we've noticed a really different like way that people are approaching it. Like the quality of the conversation is really different. People are like, okay, actually, this makes a lot of sense. We do want to try to get involved. We think this is like a really positive something. And so we've had really awesome conversations with everybody simply because I think the incentives matter, right? Like it's very, very rare, both in crypto and outside of crypto, that you find a system where it's a like not only is can it be a public good in the sense of the word that like it's an incentive aligned system which can act as like a shared resource for all of its participants, but it's also like a non-rivalrous public good and non-exclusionary public good where like the system can expand to support any number of people. It just improves with scale, and it's non-rivalrous. It's actually anti-rivalrous. So rivalrous public goods are basically public goods where like when it's like over like fishing, for example. Like if I take more fish, then there's like less available for other people, and so there's like rivalries that can come around this like scarce resource. But clearing is actually a non-scarce resource. It's an abundant resource where like the more people are using the system, the more effectively the system clears. And so it's like one of the very rare cases where you have like very, very high incentive compatibility for a bunch of competitors. Now, how does this fit into this space? So let's talk a little bit about like, the need for clearing and like how it fits in and like what problems is it specifically solving? Because I think we're talking about like competing bridges, but not necessarily talking about what problem it solves for them right now. I'll share my screen again. Okay. So let's talk about bridging really quickly. Can you see my screen?
Yes, indeed. By the way, if you click on the slideshow top right, if that's possible, it will be much better. Yeah, that's much nicer indeed.
Cool. So there's obviously a lot of different approaches to bridging. Generally, what we've seen is that the most effective form of bridging today, especially bridging of assets today, is uses intents. There's good reasons for this. Like there's like inherent trade-offs that exist around securely communicating between chains. And so if you have like lower level communication happening where like every message has to be verified by like a light client or something like that, and you want it to be secure, that's just going to cost a lot of money. And like, with the direction that bridging is going, we want bridging to become as cheap and fast as possible for users, even if on the back end it's like more expensive for like people to actually like settle and things like that. So you could think of intents as kind of like a layer 2 for bridging, where there's like you can make lots and lots of intents happen very, very quickly. And then on the back end, like whoever's making the intent, whoever's like filling the intent, in this case we call them the solver, they can go and like settle via in the past via something like a cross, or maybe not a cross, but via something like Stargate or like the canonical bridges or something like that. I'm kind of glossing over things here, but here this is the rough architecture of what any intent protocol looks like. It's not actually quite very, very complex. Basically, a user says, I want to go and deposit into Aave on Arbitrum. And a solver, who is just a third-party service provider, says, yeah, I have liquidity on Arbitrum. I can do that on your behalf. And usually solvers will do this near instantly. This can happen in seconds. And so pretty much right away, the solver fronts their own money. They use their own USDC or whatever to go deposit into Aave and give users the like A tokens. And then from the user's perspective, their transaction is done. The analogy, I mean, we kind of talked about Visa here earlier, right? So this part of the transaction that happens at the top is like the card authorization that you do when you go and you pay for coffee, right? Like immediately the transaction is completed, you get your coffee, you don't really, as a user, you don't have to think about it anymore at all. And like in the background, Visa figures everything else out. The step number 3 is then the interesting piece, right? Which is where the kind of intent protocol comes in, where the intent protocol then has to figure out, okay, how do I settle the funds back to the solver? Because the solver has like paid their own money to make this interaction happen. How do I actually repay them? Now, as it turns out, this is a surprisingly difficult problem. It's not just difficult because you have to like send messages between chains, because that's of course a challenge, but it's difficult because it creates this problem where the flow of user funds moves, from the source chain. So in this case, let's say it was like, let's say they came from like degen chain. The user's funds move from degen chain to Arbitrum. And the solver's funds, because the solver fronted funds on Arbitrum and receives the user's funds on degen chain, the solver's funds move in the opposite direction. This creates a bit of a problem for the solver because, in many, many cases, the solver's funds are basically going to move away from user demand. And that will mean that the solver has to go and figure out how to rebalance. Where rebalancing basically means the solver has to go and take their, 500K of USDC that is now sitting on degen chain because they made a bunch of transactions from there. And now they have to figure out, how do I get this money out of degen chain back to Arbitrum where it can be utilized again? Because if they don't, then it's just kind of sit there and not actually do anything. Rebalancing is really hard. It's hard because it's a really complex problem, right? You've abstracted away the simplicity of the user experience from the user, and you've just shifted it all over to the solver. So the solver is still having to deal with all the pain of actually getting between chains, but they're just doing it on behalf of the user. You haven't reduced any net complexity at all. And so the solver, when they're rebalancing, they have to go and like plug into bridges and aggregators. They have to plug into OTC desks. They have to plug into centralized exchanges, because they're trying to figure out what is the best price I can get to get my funds back. And they have to do this for every new chain that they support. They have to build liquidity on every new chain that they support, and for every new asset that they support as well. In practice, this is only really like, and of course, solvers are doing this in a way where they're also competing with each other, right? So the solver that does this most efficiently is the one that ends up winning the most flows, so they end up making the most money. This is super centralizing, because it means that in order to be a successful solver, you need to have lots of basically operational expertise, and then ideally you also have lots of money, because if you have lots of money, you can just like net out your own personal volume, right? So you could take a bunch of like degen to Arbitrum transactions, and you can net them off against Arbitrum to degen chain transactions, and by doing that, you can reduce the overall needs to rebalance for yourself. Kind of what we talked about with netting earlier, but just in a single user context, or single solver context. Make sense so far?
Yes, absolutely. And one of the key concepts here with abstraction that people, I think, often trip on is like, oftentimes people assume that the complexity is just removed, but usually abstraction doesn't remove it, it hides it from someone. In this case, exactly, from the user, right? But in reality, it just means we shift all of this complexity to sophisticated actors. And this is the same for Uniswap v3, LPing, right? And for block building, where even nowadays on block building, due to stat arb and so on and sexstacks arb, like usually the block builders are actually not just simulating and building the perfect block, they're actually even deploying their own capital, right? So like this is also what's happening here with cross-chain bridging and this stuff. Is like ultimately intents are just moving this abstraction to an act of sophisticated actors, solvers, whom we already know from CowSwap and other things, right? And this complexity is not magically removed. It's just hidden and moved to more sophisticated actors. I think is an important concept to grasp.
Exactly. So what happens when you do this, right? When you move it to more sophisticated actors, and there's a lot of complexity, and there's no reduction in complexity, then you end up in this paradigm where, like, in order to be a successful third-party actor that's doing this as a service or a business, you have to be doing it very, very efficiently, and and like very competitively, and you get a lot of like benefits from economies of scale, right? So if the people that really succeeded this, and you see this across like all of the intent-based bridges today, which is really like the majority of the real like transaction flow that's flowing between chains, is really at this point the majority of it is going through intent bridges. For almost all of them, really, like you see the same pattern, which is that there's like one or two people that are actually doing the vast majority of the order flow. And oftentimes those one or two people are people like Wintermute. Why? Because Wintermute just has hundreds of millions of dollars in capital. For them, like, this is like a marginal thing. They don't even really like, they're making money off of it, but they like, it's such a small dent to the rebalancing operations that they're already working on that it's like not something that they have to like think about. And so if you're an indie solver, right, if you want to join one of these networks as a cross, and you're like, okay, well, and everybody's trying to improve on this for sure, and like there's different projects that have like different levels at which they have abstracted away for their solvers. But if you want to go and join an intent protocol today, like as an indie solver, most of the times you're not really going to make a lot of money, if any, and it's just because like you need to be super competitive to win. So how do we? But this obviously doesn't scale, right? Like it works because Wintermute is like willing to work with like the top few chains, like Arbitrum, Ethereum, Arbitrum, Polygon, Optimism, Base, zkSync, like maybe a couple of others, and like those are the chains where they're going to be able to provide really great pricing. Those are the chains where they already have the rebalancing operation set up, and so they're not really going to like support anything else. And even if they do, it's just going to take time. It doesn't really get us to this outcome state that we said we wanted to get to, which is like thousands of app chains, right? Thousands of assets. Intents are used for every single interaction across chains, right? We live this totally chain abstracted world where like I can use any application from any chain, and and I'm able to do it with really great pricing. And like as a user, I never need to know or care what chain I'm on. To get there, what we need to do is decentralize this. We need to make it so that anyone can be a solver. We need to make it so that we can scale to like thousands of solvers, so that way we can scale to thousands of chains. So that's kind of the problem. Basically, if we fix this little domino, at least our hypothesis is that we can get to the state where every chain gets abstracted. Because we think that this is really actually the biggest hurdle that's stopping solvers from being able to like work with every chain today, based on our experience and our conversations with solvers.
In my experience as a Rollup as a service provider, working with many bridging projects and so on to deliver solutions for our Rollup as a service users, right? Definitely, I mean, at this point, I think it's we can go deeper into the bridging space quickly, right? Like what roughly I would say that there's two models. First of all, people commonly get this wrong. There's the messaging layer, like layer 0, chaining CCIP, whatever it is, right? UMA, optimistic oracles, whatever these bridging projects use. And then you have this sort of bridging / liquidity operator layer, right? And this is usually, and here we have to distinguish, right? Like the messaging layer is usually the common question of how do we attest to different chain state, right? Like how do we how do we know what's going on another chain, which is very important, right? Like and the bridging operation there, I think we have the split. We have the split between the mint and burn model, whose advantage it is, or which advantage it is that that you have basically infinite liquidity, but you're now absolutely married to that messaging layer, and if that has a fault, you have a catastrophe basically. So it is not very secure, and that's why people usually tend to shy away from that. Although for the messaging layer protocols, it is very easy to flirt with that model because it essentially empowers the messaging layer by making the messaging layer also the de facto issuer of and market maker for these assets without needing inventory. They can just mint and burn freely between chains, right? Like, for example, this famously would be the Stargate OFT model, right? And there's other models out there, other token models. But that is like a question of how secure is that? Like, it's not very secure because like blockchains for me nowadays are all about decentralized assets. And if your decentralized asset supply is completely managed and issued by such a messaging layer, you better want that messaging layer to be as secure as your asset layer. So for example, if your asset is coming from Ethereum and now you let a messaging layer, like let's say layer 0 issue that asset, that now your security is not Ethereum anymore for that asset, it is layer 0, right? Like and of course layer 0 v2 has modularity and whatnot, but any other messaging layer, Chainlink, whatever it is, right? So and this is a very big trade-off if you care about this asset, right? You lose a lot of the blockchain benefits by taking that trade-off. And the other model, which I mean across is currently probably most famous for, there's of course others, I think Connext has done this for many years as well, right? Is this liquidity provider model where you actually take the asset representation as issued on or by a blockchain. Here rollups really shine because rollups give you great guarantees about the asset issuance with the rollup native rollup bridge, right? Either with fraud proofs or ZK proofs. And now you take this asset representation and now the asset itself is secured by the rollup bridge or by the blockchain, by BNB or whatever it is. And a liquidity provider is giving you instant liquidity in that asset, and they then need to figure out, like, you give them the asset on one chain, they give you the asset on the chain where you want to go, right? And they figure out how to rebalance that and how to manage that and so on. But this model has the advantage that you're not trading off the sort of domain security properties where your asset is issued. But of course, it means that you need a sophisticated liquidity provider to manage these markets for you, to manage this inventory for you. For them, it's very hard. It's at the moment not very scalable. They need to have inventory in all of these tokens at any time and everywhere. It's very expensive for them, so fees should be higher and so on. But it's ultimately saying, okay, at least like the assets are more secured than if you just delegate everything to a messaging layer that is maybe just a multisig or even worse, right? So this is the trade-off space that you're in. I'm sure that a lot of projects who don't care so much about this decentralization and security of the assets might be happy with the mint and burn model, and it's it's cool. But you definitely in blockchain have these huge financial use cases and these huge asset use cases, which certainly should go into the liquidity model for security. And now I guess that's where Everclear is positioning and saying for these liquidity providers, we now have a solution to actually join forces and to actually have economies of scale. And ultimately, I think the question will be, yes, clearinghouses have achieved this in TradFi, but they do so in a very centralized, intermediary, trusted way. So again, probably here it is the typical blockchain play of Everclear somehow gives its participants verifiability, trust minimization, and so on. And ultimately, you don't probably have to trust Everclear that much, if at all, and the actors between each other can verify each other and can verify the system. And you don't have this trusted intermediary like a Visa that needs to be heavily regulated and so on. You have technology in between again that is a blockchain, so it's self-auditable, self-regulatable, I suppose, sort of. Yeah, that's my segue back into the conversation. What do you make of that?
Yeah, I mean, I think this, I agree wholeheartedly. I think that there's what we're seeing is, and I'm kind of like drawing something here, but and I'll explain it a bit better. Maybe.
Oh, good. Just for the listeners, time to get your phone screens up again, or watch this on your computer or TV. And Arjun is live gigabraining here. I think trying to give you a visual representation, probably related to what I just said verbally about the current state of cross-chain messaging versus liquidity provisions, and the two types of bridging, which I could broadly say are mint and burn models versus liquidity provider market making models.
Yeah. Okay, so let's talk about this a little bit. So basically what we've seen, so I think one of the big challenges that exists in the bridging space today is that, like, and this is something that we've tried to push back on and fight against for a long time, but it's just something that hasn't really stuck. And you're kind of seeing this, like, this is happening a lot better in the chain abstraction space, just because I think everyone is more collaborative. But in the bridging space, there is modularization. It's already happened, regardless of whether or not people want to admit it. Like, they are technically falling into categories. So, for example, like Layer 0 is a transport protocol. This is something that we've sort of pointed out to them years ago, that they're a transport protocol that effectively competes with things like IBC or Hyperlink, because there's no sort of inherent security mechanism, right? There's a modular security paradigm where you could plug in stuff like clients or wormhole Axel or ideally eventually things like eigenlayer ABSs, and that allows you to secure the message payload that goes from one chain to another. Generally speaking, the challenge that exists today for expanding to new chains is that each of these different pieces is responsible for a different piece of the puzzle, right? So transport is what is responsible for the process of chain expansion. This is the problem that transport solves. Having a singular, very, very simple, easily extensible transport implementation that can go everywhere. And this is a big part of the reason why we really like Hyperlanes, because they were really the first people to do this very, very effectively. And they have the most performant system for it. Having a simple, unified inbox, outbox that can go to every chain is a huge, huge, huge problem to be in. A simple language that every chain can communicate over is a very, very is a really critical part of how you can bring bridges and other infrastructure to new chains. And then, of course, in order to make it work in every case, you need to have security, right? So you also need to then plug into whatever the best security mechanism here is. Make sure that, I don't know, verify messages.
Yeah, I mean, I would say this is like deposits in a bank almost, right? At the end of the day in Visa, the money is somewhere in a bank secured, right? Maybe figuratively speaking.
Go further. I would say the best way to think about this is I think this is one of the big issues that exists today, is that a lot of transport protocols try to conflate being a transport protocol, which is a messaging protocol, right? The analogy should be like TCP/IP, and the analogy for this should be like TLS, right? Maybe these things need to be swapped. But a lot of transport protocols today conflate being a messaging protocol with finance. So they will build like a transport layer standard for sending tokens or things like that. And I don't know if that makes a lot of sense. And the reason it doesn't make a lot of sense is because you're basically muddying the waters here, right? Like there isn't just one transport. There's not going to be just one transport. And so if you have like transport layer asset specifications that are not like more general, then it creates like lock-in, where if I'm a rollup and I use a certain transport layer, then I'm like locked into that specific asset specification. I think the idea is that like having, it's an interesting question, right? Like what is the best way to represent assets in this kind of a system? And our hypothesis is that it's better to kind of represent them higher up in the stack, because like this is for the same reasons why like you don't have today you don't put like card payment, like there's no protocol for card payments built into TCP/IP, right? Like protocols for card payments exist, they exist higher up in the stack, they're built on top of HTTP. And there's that like having that like level of abstraction between layers is like kind of what keeps things secure on the internet, and kind of what helps like separate concerns, such that like one protocol doesn't necessarily have risks that come from like being dependent on a bunch of stuff that is outside of what its scope should be.
Yeah, maybe to draw my analogies here, the way I think about the stack, and feel free to contradict me there. The security settlement that you have here, roughly speaking, like if we're talking about blockchains, ultimately, yes, a lot of times it's about assets, NFTs, whatnot. But even if you just want to have a pure data model, it's still normally a state machine, right? Like, so this is like a transactional database, a state machine, whatever it is. So this data is there. It's mostly nowadays tokens, right? And tokens could also be IDs or whatever it is, right? Or yeah, tokenized stuff like NFTs for your post on Lens or whatever it is. But yeah, these things, like you could think of this as the databases of the Visa model. You could think of these as the ledgers of the banks that are securing the stuff, and maybe even the actual bank vaults. Like for me, in my thinking, so TLS, like you drew here, wouldn't be my analogy for this layer. The bottom
yeah, it's
here,
not a great analogy.
It would be more like, I don't know, like it is the actual database, the ledger that we need to secure. And the nice property of blockchains, of course, is what they are, right? Like compared to a Wells Fargo. The transport TCP/IP makes sense for me. And for me, like having an application on top, or rather like having TLS like a secure transport layer, then would be more like this sort of egg layer thing, where it's like, okay, we're now like, I suppose egg layer or OP native interop and so on. They're also basically somewhat a messaging layer, a transport layer, but they're saying we're not like HTTP
for block space.
Yeah. Like for me, they're like a specialized version where it's like, this is secure transport, right? Like this is not HTTP anymore between these chains. This is HTTPS, because everything comes with an aggregated proof and whatnot. So this is sort of like, for me, also interesting, like essentially what egg layer and other like ZK bridging or ZK interop mechanisms are trying to build is a transport layer that is like TLS sort of cryptographically secured, right? And yeah, and then there's all the other things that you have in here. You won't comment on, but maybe you can riff on this.
Yeah, so I would say like effectively like so I guess the proof aggregation, I guess like what proof aggregation is doing is it's like there's two pieces of that, right? There's like making sure that everybody has like a shared view of the underlying state of all of the other systems. So there's sort of like some like final database entry. So it's its own mechanism for settlement. And it's like posting to this mechanism for settlement. But the more important thing, and this is actually it's the thing that I think people don't realize, is it's ordering. And so ordering is like, we talk about ordering a lot in this space, but ordering is just locking, right? Locking on a database. It's like how do we queue and lock on this database most effectively? And that's, I think, what I would describe as like block space clearing, because like technically speaking, Everclear is also doing ordering. It's just like ordering solver settlements. And so like there's some like really interesting parallels here. We're getting a little into the weeds here, but I think a really important piece to realize here is that there is delineation between these different parts of the stack. And like, in order for us to be able to get to new rollups and to have every single new rollup like launch with the best possible both like fantastic security, but then also like launch with liquidity, you need to have all these pieces, right? So like, for example, I can go and like deploy Hyperlink to a new rollup, but if there's no security mechanism, I can go and mint as many assets as I want. If there's no security mechanism, that like, what's the point? You don't even run a rollup, just run a centralized server, right? Like at that point, as a project, like if all of the assets on your system are custodial, then the implication there is that you're effectively just running a server. And so I think the like if we want to get this to this ideal end state, right, where we have like verifiability of transactions happening on blockchains, and like we know that every single asset that is being bridged into this chain is backed by like the same core security properties that backs the rollup, right? So which is Ethereum, or at least like the DA layer that you're posting to. Then we need to kind of assume that like this is a dependency. And we need to assume that like, okay, if this is a dependency, then transport's not going to be super cheap, right? Like if you're verifying a light client, then sending a message across chains is going to cost money. And if you're doing that, then you need this stuff. So what is all of this? This is basically L2. I wonder if there's like a...
So basically, just FYI, we're saying that you have the base layer that you need, like the layer one, like blockchain sort of in this model. They usually have to be verified. We know that now this is very expensive. Famously, IBC on Cosmos has a model for this with light clients. We're now seeing the beginnings of ZK taking care of this somewhat, right? Like, but then you have the multi-sig bridges and whatnot that essentially are not really verifications, but more attestations, right?
Exactly.
Yeah, and you're basically saying, given that these chains are a dependency and ultimately, and they cost, like verification has a cost, we have to pay that cost in that model, right? And now you're in this L2 space, which you here say are clearing, solvers, auctions, roll-up, shared sequencing, proof aggregation, and so on.
Yeah, exactly. Okay, so let's jump back to kind of Everclear and where this stuff fits in. So we know there's this problem, right? This problem that we talked about, which is that there's all of this like liquidity that needs to be moved between chains. This is happening through intent solvers at the moment, but it also exists throughout the space. So like if you like dig deeper, you find that like market makers are struggling with this, arbitrageurs are struggling with this, centralized exchanges are struggling with this. Like it's just inherently a problem. Like whenever you want to move liquidity across all of these different state machines. So how do we solve it? I think historically, every single project that's out there has basically tried to solve it by being like, okay, well, we are going to go and create our own liquidity system. We're going to go and bootstrap a bunch of liquidity on it, and we're going to try to make it the winning system. And it feels like what always ends up happening is that just fragments things further, right? Because it just creates another bridge, another liquidity pool that you have to route over and aggregate and things like that. We decided we've kind of been thinking about this problem for a long time because it just underpins everything that we do, and so we kind of wanted to go a different direction. And a lot of this came from this very key insight. To be honest, like when we pulled this data, we were actually shocked by how high this number was. Basically, on average, 80% of the volume that's going between chains today is nettable. And that means that like for every $1 that you send into a chain today, about 80 cents flows out in a 24-hour period. That means we're bridging about 5 times more than we need to. And this is true for like everybody in the space. I mean, it's maybe not true for the end user because the end users just want to get their funds immediately and they don't really want to care about like waiting. But for anybody that's on the back end that's rebalancing liquidity, this should be really shocking because it means that you're actually spending way more money rebalancing than you actually need to be. And this is, we talked earlier about how like clearinghouses and clearing systems need to have this like global view, right? This is the global view. We're looking at what is the aggregated sum of all transactions that we can find from public data, and ideally, if we could get private data as well, I think we would actually find that this number is even higher. So that includes things like private OTCs, like off market sex trading and stuff like that. Any questions on this? Because I think this is something that like I think is super. Maybe like the most important insight that we've discovered so far.
It's an amazing insight. It's like the addressable market here, right? The value add.
So what did we kind of do with this? Well, what we realized, of course, was like, well, there's this opportunity for netting. If you can net off, there's this like really interesting coordination game that you can play where if every player is not rebalancing on their own, instead if they're working with each other. This includes all of our competing bridges. It also includes things like dexes that are headed towards becoming intent-based bridges. So things like InSwap X, right, or 1inch is going in the same direction. Like if you're looking at all of these projects, everybody's going to run into this exact same problem. Well, that means there's an opportunity here for everyone to coordinate with each other. And so we realized that there is space. There's space for this clearing layer. And I can kind of talk through this stack diagram. It's a little bit similar to what I started preparing here. But we realized that there's this like emerging stack that is coming together around chain abstraction, where we are saying this chain abstraction stack is the like almost like the layer 2 of bridging, right? This is where like we have a way to do secure communication across blockchains today. We know, for example, canonical bridges are like secure mechanisms to do communication across blockchains. The only problem is that they're slow and expensive, and they have to go through Ethereum, right? But if we could still use those canonical blockchains, canonical bridges, since they are the best option, and we could just make them faster and cheaper by having a layer 2 on top of them, then you get the best of both worlds. You're not having to sacrifice security. You're still getting the same like security properties that rollups give you, but you're delivering on that experience that users actually want. And in fact, you're beating the bridges. You're just like stuff like across is so much more efficient than like any transport layer bridge that exists today. I mean, to the extent where like like projects like Axel have fully like headed in this direction where they're saying, yeah, you know what, like we think it's most important for intent protocols to come and build bridges on top of us because we will provide the underlying infrastructure to get to new chains and to get assets and things like that. But the intent protocols are really what kind of matter to like for like the end user experience. So where does Everclear fit into this? Well, we realized like intent protocols, we kind of talked about this earlier, but there's these 3 steps, right, with an intent protocol. There's this like intent gets created and is auctioned off, intent gets executed, and then the intent gets settled. And we realized that this maps very well to where projects are working today. So there's like wallets, like the provisioning layer, where like the user is holding their funds and they say, okay, I want to make an intent. There's the auction layer where the intent is now kind of broadcasted and is and like solvers go and attempt to like compete to figure out who will fill it. And then there's the like solving layer, which is where the solvers go and actually execute the intent. And then after executing the intent or any other interaction across chains, all of those systems can plug into Everclear. Everclear then allows for solvers or market makers or whoever else is like running these systems to be able to net off their transactions against another. And then Everclear is this like abstraction layer that then sits between all of the solving stuff that's happening above and the underlying settlement backbone, where that settlement backbone is stuff like canonical bridges, it's stuff like centralized exchanges, it's stuff like, layer 0, hyperlane, whatever, right? Whoever has like minting rights of a token, whoever has like the like CCTP, for example, for USDC, whoever is like whatever like most enshrined mechanisms exist for an asset to get between one chain to another. Now, what's interesting here is that there's a secondary function that Everclear also performs, and this is also quite similar to Visa, which is in addition to netting, right? In addition to netting all of these like transactions for solvers, Everclear is also negotiating relationships between these underlying systems. So, for example, today there's a bit of a shit show where like CCTP is the best way to send USDC between chains today, right? It just is like it's effectively free, and like for any chains where it's supported, CCTP lets you make a transfer of any amount of USDC between 2 chains in like 20 minutes. It can be faster through things like across and through intent protocols, and that's an important thing that like I think it needs to exist. But aside from that, you're not going to beat CCTP on pricing. But the problem with CCTP is it's not everywhere, and it's going to take a long time for like the protocol to be available on every chain, right? Like the rate of chains is growing much faster than the rate at which CCTP can add new chains. And so if you want to give like amazing USDC pricing, but you're transferring from, say, for example, like Gnosis chain to Arbitrum, how do you do that, right? Because CCTP is not supported on Gnosis chain, but it is supported on Arbitrum. What you kind of realize is that there's, in addition to this like netting problem, there's also this just like huge fragmentation that exists on the settlement backbone, where like Some bridges support some chains, but not others. And like you have like OFT, like you have projects that have deployed with OFT on like 3 chains, and then they've deployed like with canonical bridges on a bunch of other chains. And like, how do you reconcile those things, right? Like FraxFerry is a good example where like Frax has worked with Axelar to go and deploy to like chains like Linnea and a few others. And then they also have FraxFerry, which is their own enshrined bridge to bridge Frax to like a bunch of other ecosystems. So how do you reconcile all of that so that like a solver that's going and like settling is not having to go and is still getting the best possible pricing despite the fact that these things are fragmented? That's also what Everclear enables, is it allows for like netting off, I have this transaction that's going from Gnosis Chain to Arbitrum in USDC. I'm going to net off the basically lock and unlock mechanism of burning of bridging from Gnosis Chain to, let's say, to some other chain against another mint and burn that happened from like Optimism to Arbitrum. And so the solver still gets the pricing that they want. Effectively, they're still technically using CCTP to settle, but you're not having to like route the transaction through some random intermediary chain to get there.
Really cool, nice. This last point, can you explain it once again in a nutshell? Like, I think it was a very important point.
It's a really, really hard concept, but I'll do my best. So this is another thing I think a lot of people haven't realized. Like for a given token, right? So let's say let's go back to Frax as we mentioned, right? So let's say this is like Frax token canonical implementation on Ethereum, right? And you want to get Frax to some other chain, you want to get Frax to some other chain like Arbitrum, or actually, let's say you want to get Frax between Linnea to Arbitrum. How do you do this today? As it turns out, it's actually quite difficult, and the reason it's difficult is because Frax on Linnea, Frax on Linnea and Frax on Arbitrum use different bridges. So this happens through FraxFerry, and then this happens through Axelar. It's just this is just a delineator. So how do you actually make a transaction going from Arbitrum to Linnea using Frax? Now, the way that this gets solved is that you normally have like some intent protocol do it, right? So like someone like Across comes in and says, hey, I'm actually just gonna I'm gonna put a solver here. And what the solver is going to do is the solver is going to go and immediately give Frax on Linnea to the user.
Exactly, and then rebalance back via the FraxFerry from Arbitrum to Frax, and then the other bridge from Arbitrum to Ethereum, and then the other bridge to Linnea, and that's this very inefficient rebalancing that needs to happen for the solver. If ever they run out, and probably in most cases, especially for slow 7-day withdrawal Rollup bridges, actually what ends up happening is these solvers don't rebalance, they just inject new capital, and this is extremely capital inefficient, right? Like if they want to fill a user's intent and they're out of stock on that chain, they're just going to look and inject capital either quickly from their centralized exchange account, maybe they go to a market maker, maybe they borrow it from other, whatever it is, but they're paying fees. And this new capital is just very inefficient because it could be elsewhere earning interest. It could be in other earning interest for that solver or whomever, right? Yep. Like, so actually, I think, but yeah.
So basically, you're rebalancing through Ethereum. So automatically, that's also increasing your cost massively, right? Because you're rebalancing through Ethereum, you're now paying a ton of gas costs for it.
And time, gas and time. Ethereum is slow, right? Time is expensive too.
Exactly. And so what we kind of realized is that there is a very this is sort of a hidden benefit to having like a clearing layer, is that there's maybe not even that hidden, but there's the clearing layer can be the system that is negotiating these relationships when the solver goes to settle, right? So you can have Everclear here, and Everclear can be responsible for looking at a bunch of ideally what should happen is that these protocols should just integrate into Everclear as well. Because then you can kind of negotiate these relationships and do all of the rebalancing in Everclear itself. But even if you don't do this, right, even if Everclear isn't actually used here, what can happen here is that Everclear can basically look at other solver transactions that are happening, right? So say there's another solver transaction that's happening that's going from Linea and is going out to some other chain that is supported by FraxFerry or whatever, right? Say it's over here somewhere. And so what Everclear can do is say like, okay, well, actually, there's these other solvers that are also making transactions at the same time, and I'm seeing that there is a solver that is exiting Linea at the same time that the solver is coming in, so I can net those off against one another. And what I can do is I can net off the inbound transaction from FraxFerry here, so the outbound transaction from FraxFerry here to the solver, from Arbitrum here to the solver that would have otherwise been rebalanced by FraxFerry against a transaction that is using FraxFerry from Ethereum or something like that. So it still replenishes the solver's liquidity in the same place.
Let's say we have two intent systems, two solvers. Alice gives solver A tokens on Arbitrum and gets from solver A tokens on Linea, and Bob gives solver 2 tokens on Linea, and Bob gets from solver 2 tokens on Arbitrum. Now solver 2
tokens on, for example, Ethereum that could be pushed into FraxFerry on Ethereum, or tokens on Optimism that are coming from a recent FraxFerry bridge.
Yeah, exactly. And now we look at this global picture and we basically say, hey, you parted with tokens solver A on this chain, but solver B has new tokens on this chain. Solver B will give you these new tokens here. Solver B parted with tokens on the other chain, but solver A has new tokens on the other chain, and they make that exchange there, all via Everclear, basically.
Exactly.
Yeah.
Yeah.
Okay.
Cool.
And this is also what we discussed earlier a bit, but essentially this sort of is the essence of Everclear, right?
Exactly. Yeah. This is basically in a nutshell where it sits and what it aims to do.
All right, cool. And your point about like that specific point you made that is often overlooked about it negotiating is basically it is negotiate like I think there was this one line in your awesome stack chart where it said it's netting the invoices, but it's also finding the best place to settle, which I think exactly. that actually has a lot of connotations, right? Like that has a lot of questions. That's probably the biggest complexity. Like how do you pick where to settle, right? Like especially in this very complex day of clearing where there's many in and outflows of solvers on multi-chains, right? So like how do you actually pick where to settle is probably a pretty difficult nut to crack, or is it not?
Yeah, it is. So the idea here is like we don't think that there's one answer. We think that there's an infinite number of potential possibilities that is indexed by assets, chains, like whatever bridges are available on those chains, whatever permissions that asset has given around minting, available liquidity at a given time, like forecasted demand. We think that there's a near infinite space in which you can actually optimize how clearing and settlement happens. And so I think at launch we've simplified things, and we have this like relatively simpler mechanism that uses a Dutch auction that does like netting and things like that, and then just like prices liquidity, and like we kind of assume that if there are these other opportunities where there's a settlement layer that is more efficient, some arbitrager will come and like basically arbit, and like there will be some efficiency that is lost to fees for the arb, but it'll still be good enough. But in the long term, the idea is that the strategies that are used for settlement on Everclear are themselves modular. And anyone can actually write these strategies. You want to make it an open system where solvers are the ones that are kind of opting into whatever mechanism they want to use to settle. And so you as a developer, or say you're like a data scientist, or you're Gauntlet or economics design, or like some other like CAD modeling firm or something like that, right? You as an organization can be like, okay, well, I'm looking at a bunch of data here and I'm finding that there is a way to make an improvement. There's a contract that I could write on the system that actually improves how settlement occurs, or improves how like netting occurs, or pricing, how pricing occurs. So I can basically come up with alternative models for how the system settles and clears for specific use cases, and solvers at the time of transaction execution can opt into them. Our thinking is that there's like an interesting ecosystem that can be built around this, where like you basically have these things as like strategies. These strategies can earn fees, right? Because these strategies are basically like optimizing clearance, and like the more people that use them, the more volume is going to flow through them. The strategies have network effects associated with netting, but there is still a need to have many different strategies potentially. And like we think it'll look a lot like a power law, where there'll be like a few strategies that are really, really heavily used in a bunch of places because the network effects of netting are really, really strong. But then there'll also be other like longer tail cases where it will make sense to use just like, not net as much and like use something like CCTP because it's just a more efficient settlement mechanism for certain cases.
Cool, nice. All right. I think you can stop sharing again, and then we'll wrap it up here. I mean, it is a big topic. Like, let's be honest here. We definitely don't cover everything. I think we sort of agreed to finish in 5 minutes roughly. If you can stay a couple of minutes longer, feel free. But yeah. So, I mean, there's still a whole lot of questions that I would normally ask about Everclear itself. What are the software components? Now, we know that you're using Gelato for your layer 2 chain. What is the chain doing exactly, right? Like what other components are there? I think you're also using Gelato automation or whatever it is for certain aspects. Maybe you can, without going into too much detail, sort of just give an overview of the key components that make this system tick. Yeah. And essentially what are you leveraging the chain for ultimately?
So there is, as you mentioned, there is an Everclear rollup. We think it's actually really important for this rollup to exist. And the reason is that all of the actors that are using, so effectively Everclear is a coordination mechanism. It's like a coordination computer for all of the users of the system, right? So this is all of the like solvers or market makers, whoever is like using the system. All of these actors are like in the market, they're competitors, right? And they're cutthroat competitors where they're like competing very aggressively against one another to win order flow. And it is like truly like dark forest shit out there. For these actors, right, like minuscule changes in like fairness can result in huge amounts of changes in things like profitability over time. So for example, like if a system was preferentially settling some people over others, that would be a form of MEV. And that would actually, for these kinds of financial actors operating on very thin margins, that would mean like unprofitability. So for us, one thing that we kind of realized pretty quickly was there needs to be like a verifiable, like the strategies that are used to do clearance and settlement in this case need to be like obviously eventually like publicly written, but also they right out of the gate need to be verifiable. And there needs to be like a credible commitment from a system that if a given strategy is not executed as written, that system can get penalized. And so this is kind of what we get out of the rollup, right? Like what is a rollup? It's a verifiable server, effectively, right? And it can be decentralized eventually to like replicate the state machine and to replicate who's making updates to the server. But effectively what the rollup is doing is emulating a chain-like environment. And it is allowing for anyone to verify what is happening on that chain-like environment and dispute in case something goes wrong. So in our case, we're running an Arbitrum Orbit rollup in partnership with Gelato. The Orbit rollup has fraud proofs out of the gate. We'll be using off-chain DA for it, but right out of the gate, it will mean that like market makers and solvers, if they see that like the system is not behaving the way that it says it should, they can slash the rollup. And they can penalize like us, or I guess Gelato as the sequencer. This is like a really, really critical piece, I think, that needs to exist, or at least this kind of verifiability is something that needs to exist, even if like the economic incentives are something that get like improved on over time. This kind of verifiability needs to exist for the system to be neutral. Beyond that, there's a couple of other things that we do. So we use Hyperlane out of the gate for messaging as a message transport. Why did we use Hyperlane? I think, like, to be honest, we looked at all the message transports that are out there today. Hyperlane was the only one that supported all of the chains that we wanted to be on. We wanted to maintain like the chain support that we have and also find a way to expand really rapidly. And then beyond that, there's a couple of other things. We saw that Hyperlane performs better than really everything else at the market at the moment, and that the direction that they're going towards having just truly permissionless expansion. So like, you know, anyone can go and deploy Hyperlane anywhere really maps well to like what we want to do, which is that this system should also be very permissionless, right? We want it to be the case that new rollups can go and deploy Everclear without ever having to like talk to us at all. Like that's how protocol should work. Like you shouldn't have to go and talk to a DAO or a foundation to be like, hey, can I get support? It should be like the internet, where it's like, if I'm spinning a new server up on AWS, it should come connected to the internet. I shouldn't have to go and ask someone to connect to the internet. That would be crazy. So we use Hyperlane to kind of perform that function of like go and connect to every single other chain. And then under the hood, we are expecting to kind of work with Hyperlane's Eigenlayer ABS. We're like really excited to support the development there. We're super bullish on Eigenlayer as a broader mechanism, and we think that the ability to rent economic security directly from Eigenlayer to power the system means that you get this, again, very, very explicit verifiability, right? We can say, okay, there is explicitly $3 billion worth of economic stake securing this message, and this message is transferring over like $1 billion worth of settlements, and so we know it is secure. Rather than the kind of hand wavy, okay, there's X many validators that are supporting this, and we don't really know like how many of them are online, and like we don't know, things like that. So that's a big part of like how we've gone about making these decisions. Yeah, and then aside from that, the system itself is not super complex. There's like a gateway contract on each chain. I think I've mentioned that like is like the kind of face of the protocol on each chain that people that like intent projects, solvers, etc. are interacting with. And then the rollup itself is running like a set of contracts. All of the like system logic is just described as contracts, just to keep things simple and to keep it verifiable. So the rollup itself is like running a set of contracts that is like running this like process of, generating invoices. Invoices are like IOUs from the system to go that get settled, and then like clearing those invoices.
Cool. So roughly speaking, like you said, the rollup is a verifiable server, a verifiable computer. I suppose what it does is it keeps count of the day's transactions on all domains that Everclear is serving. And then you have Hyperlane to be the messaging transport layer between the rollup and everything else to actually disseminate, the settlement and clearing sort of or things, I guess, sort of. You have your auction probably on the rollup as well and so on. So roughly speaking, yep. Solvers or liquidity providers put their pockets of liquidity in these gateways. They trust the Everclear computer. They don't just trust it. The cool thing about a rollup is they can verify it. I assume like at some point ZK might be really big here because right now you have this awkwardness between the fraud-proof period and whatnot. Like maybe if you settle once a day, it's not that much of an issue because you can actually wait for a fraud-proof challenge period to come in and so on. You can get these times down. But yeah, I guess the sooner you have a verifiable compute also on all of these gateways, the sooner we can like the quicker the settlements are. Like I don't know how often Visa settles, but like maybe Everclear settles at some point every 30 minutes. Who knows, right? Like.
Exactly.
And we don't have to go much more into it. Like maybe a part 2 would serve justice, but I think that's super cool. Maybe the last question, given that you're a rollup, what is the relationship between the rollup chain that you guys are settling to? Is it like a bit of a burden, or does it have any special purpose?
Do you mean why have our own rollup?
I suppose like why not have a sovereign rollup, for example, or so, right? Like I mean, what is like? Are you like there's no assets on your chain, right? Like it is a rollup computer and so on. Yeah, it's maybe a bit of a spicy, interesting question though. But like I see this a lot nowadays. People use rollup stacks a lot, but sometimes they don't use the rollup bridge. So it is like the question is. Ultimately, rollups are a lot about the native rollup bridge with the L1 and so on. And so I assume Everclear is one of these interesting tooling chain examples where the rollup bridge isn't actually being used much, right?
Yeah. So like the rollup bridge in our system is used to like do the thing that the Rollup bridge does very well, which is like post batches to Ethereum and like verify the state on Ethereum, and verify like state transitions on Ethereum, and dispute if something goes wrong. The bridge is not actually used to like mint assets on the Rollup. I guess there's an interesting question as to like how do we want to represent invoices, and so we've been doing some thinking around this. Like you could potentially represent these invoices as just like credits on the Rollup, and like allow people, and then it's effectively like you're just sort of transacting the assets anyway, and like you could do whatever you want on that Rollup as well. But there's like open questions around like, well, does that increase the like the, you know, then what role does this play? Does that at that point, like, why not just do this on some other chain and things like that? I would say from our perspective, there's like some things that we benefit. So from our perspective, we think this is a use case that is uniquely served by an application specific rollup. I don't think it makes sense for this type of, like we effectively, when we were trying to build this ourselves earlier, we were effectively building an in-house rollup anyway. And so we ended up realizing, okay, it just makes sense to go and use, you know, something like Arbitrum Orbit instead. I don't think that this kind of a system could exist outside of an application-specific rollup context, and there's a few reasons for it. The first is, like, as I mentioned, verifiability. The second is that the system is not like a traditional chain, because the system does not collect fees, gas fees, in the same way that a traditional chain does. The system pays gas fees, right? It pays costs to Ethereum to like post proofs and things like that. But the fees that are within the system are actually collected as part of settlements. And so like we can't just do something like deploy it on Arbitrum or deploy it on some other chain and like collect fees, because effectively like our DAO or foundation or someone would have to be then responsible for figuring out how to like manage this whole like giant accounting nightmare. And then even beyond that, the second piece that we get is kind of the like sovereignty neutrality of having our own rollup, and like the configurability of being able to say like, okay, well, we want everything to be gas abstracted. We want the system to be posting to ICANN. We want the system to like have like certain supporting functions that allow it to like not necessarily behave like a traditional programmable rollup, but instead behave as this more custom thing. Because we, you know, it's like in all of these systems, right? Like we've prioritized historically building like fully expressive, like EVM compatible rollups that are just like totally expressive computers. You can build whatever you want on top of them, but there's a range. Like when you go and you create like totally expressive stuff, people can go build anything on it. But you don't always want people to go and build anything on your system, right? You want people to go, you might want to like funnel activities towards certain specific kinds of kinds of development. And you might also want to limit the security risks that come from having just arbitrary programmability. And so that's something that we're thinking really deeply about, is like the sovereignty aspect of this is like a really critical part of what helps Everclear succeed.
Cool. Nice. All right, let's wrap it up here. Definitely have some follow-up questions. This is a super interesting topic. But yeah, let's say, I guess, what utopia are we optimizing for here? I guess this is a lower barrier to entry, more capital efficient way of making token markets cross chains. You can now fill more orders with less capital, similar to how Uniswap v3 allowed you to, with less TVL, make swap markets on Uniswap, right? Like similar here, you can now deploy less capital to fill more orders in a given day, which is great, right? That's the idea. Now, of course, you still have competition. Of course, the big guys will still fill more than you, but yeah, at least your per dollar of capital you have, you can fill more orders, and that's great for everyone, big and small. It raises the bar for everyone. So and lowers the barrier, raises the bar and lowers the barrier. So yeah, cool. Would you say that's the mission basically?
Exactly. Yeah. Let's make crypto usable.
Nice. And I think there will be very nice side effects from this, which essentially, if you look now on DeFi Llama TVL charts, there's a shit ton of money locked up in liquidity bridges. And this money, just like on Uniswap, people to this day don't understand that Uniswap v3's core metric isn't TVL. Actually, the core metric should be like just on order books, like they don't have TVL. It's more like how many trades can you facilitate, right? Like, and like technically you can look at all of these pockets of liquidity provider bridges on DeFi Llama today, and a big chunk of them, like 80% as per one of your charts, right? Should technically not just sit there idly, and could technically be used elsewhere. either to make even better markets between chains, between more chains and so on, or to have them in Aave, have them in Uniswap, whatever else. It's like DeFi will become more efficient thanks to Everclear.
Yeah, absolutely.
Awesome. Proud to be working with you guys. And of course, we've been working even before Gelato's Rollup as a service on Connext relaying and whatnot. So happy to see you all using our Rollup as a service, our middleware services. And yeah, thanks for coming on Gelato today.
Of course. Thanks for having me, Luis. This is awesome.